Alright, so what we're going to be looking at now is the chain rule. And so we're going to be using differentiation on things that's not just x squared. We're going to be looking at, okay, what if I have 3x squared plus 2 to the fourth? Okay, and we're going to see if we can differentiate this. And in this case we can, and we're going to be using the chain rule to help us out with this. So the chain rule is that it's if f and g are differentiable, so two functions are differentiable functions, and then the composite function f of g of x is also differentiable. And so essentially what's happening is that if we have something simple, 3x plus 2, actually let's just go 3x. So if we just have 3x squared, okay, and we want to find the deviation or the derivative of this. What we would do is we would take and replace 3x and say, okay, that's going to be u. So 3x is now u. And so I'm going to write u squared, okay? Now, if we want to take the derivative of this, that would be 2u. And now what we're going to do is that we're going to multiply it by u prime, or the derivative of u. Well, what is u? U is x, or 3x. U prime would be 3. So, now we're going to take these and we're going to plug them back in. Plug this back in for the u and plug this in for u that. So it would be 2 times 3x times 3, which gets us 18x. Okay. Now if we were to distribute this right here to check, we would have gotten a 9x squared using the power rule. Drop the power, multiply it by 9, 18, subtracted by 1, 18x. So as you see, it gets us the exact same thing. Okay. So that's what the chain rule is that you substitute or replace the middle part, and then you find the derivative of the whole thing, and then multiply it by the derivative of the inside. Okay, so we'll do another example. So right here we've got the square root of x to the fourth plus 1. So what I'm going to do is that I'm going to say u is equal to x4 plus 1. Okay? So now what I have is I can say that f of u is equal to u to the 1/2 power, okay, which is what a square root is. The derivative of this, f prime of u, would be 1/2 u minus 1/2 times the derivative of u. Okay? Other notation for this would be du over dx. And now if we go back up top, u prime would be 4x to the third. So now we're going to plug this back in for that u and plug this in for u prime. And so our final answer would be 1/2 times x4 plus 1 to the negative 1/2 times 4x cubed. And then we would multiply this, simplify it, and we end up getting 4x cubed all over 2 square root of x4 plus 1. And there is an answer. That would be fine. Okay? Or you could reduce it, getting you x cubed all over square root, or 2x cubed all over the square root of x4 plus 1. Okay? And that would be the derivative of f of x. So for the chain rule, you take the derivative of the whole thing and then multiply it by the derivative of whatever is inside. So one thing you can do is use this substitution method, where you replace the inside with a variable, find the whole thing, and then multiply it at the end. But you've got to make sure you've got to multiply whatever's inside but to the whole thing. Okay. All right. Some Leibniz notation for this. So dy over dx is equal to the f prime of u times g prime of x. That's just one way of writing it. Or you could see it as df over du times du over dx. And what happens is that these end up canceling, leaving you with df over dx, which is the derivative of the function f a derivative of the function in terms to x. So this is just other notation you might see. All right, so let's look at this one. So my u is going to be 8x4 plus 5. Okay. My u prime, or the derivative of this, would be 32x cubed. My f of u would be u to the third. And my f prime of u would be 3u squared. And so now what my answer is going to be is it's going to be f prime of u times u prime. Okay. And then after we have that, we've got to replace it back with our x's. So this would be 3 times u, which would be 8x4 plus 5 to the second times 32x cubed, which is here. So as you see, we took this part there, we took this part and put it in for the u, and we put this part in for the u prime. Okay? And then you would multiply that, simplify it down to get what your answer is. Okay? Which, as we see down here, it's down there. Okay? And this should actually have a 3, and this should be squared. Okay. All right, so now this one. This one is a little more complicated. We've got to use the product rule for this. So the product rule says that we're going to take tan u times the derivative of secant, which would be secant tangent of u, or actually of v because they're different, plus secant squared, which is the derivative of tangent of u, times secant v. Okay. So our u is 4 minus 3x. U prime would be negative 3. Our v would be 3 minus 4x, and our v prime would be negative 4. So see, all I'm doing is I'm replacing this with u, and I'm replacing this with v. Okay. Now, wherever we took our derivatives, there is our derivative. We're going to multiply this also by v prime. And this one, we took our derivative with u, so we're going to multiply it by u prime. U prime. Okay. So that means we're going to have tangent of 4 minus 3x times v prime, which is negative 4, times by secant of 3 minus 4x times tangent of 3 minus 4x. That is the first part. And then we're going to add that to secant squared times u, which is 4 minus 3x, okay, multiplied by u prime, negative 3, multiplied by secant of 3 minus 4x. Okay. And then you would simplify, see if you can take anything out. But this is basically it. So as you see, here's our u prime. Here's our v prime. Here is our f of v, f prime of v. Okay. Here is your f of u. Here's your f prime of u. And here's your f of v. So as you see, what you want to do is you kind of want to put everything, take out, make sure you have everything located, and then you want to plug it all into each other and then multiply it through. Okay. So this is all the work for it. This PowerPoint will also be posted so you can follow along, and it's there. Okay. So now let's look at this one. So what we're going to do is we're going to say that f of u is equal to sine u. So that means f prime of u is going to be cosine of u times u prime. U is equal to x squared plus 4x. U prime is 2x plus 4. So we're going to take our u prime and plug it in front, and then we're going to take our f prime of u and plug it in there. So now we've got cosine of x squared plus 4x, and now we would multiply this together, and we would end up getting 2x cosine of x squared plus 4x plus 4 cosine x squared plus 4x. And so then you would multiply those, and then that's basically as far as we could go. You could either take either one of these as your answers. So again, what we've done here is that we've got u prime times f prime of u. Okay. And then we're just multiplying those together. So all chain rule is that if you have f of x, okay, you're going to say whatever's inside you're going to say is u, so you're going to substitute u, and then you're going to take f prime of u and multiply it by u prime. Okay. So this has, the u has some part inside of it, and then we just take the derivative of the whole thing, multiply it by the u prime. Okay. And that's basically the chain rule. Okay. So this is very important because you can use this over and over and over again and use it for different things. So like another example you could do, you can find the derivative of, let's say 3x squared minus 4x plus 2 to the 8th power. And you would use the chain rule on this, because the inside would be your u, and then the outside would be your f sub u. You would take the derivative of each and then multiply it by u prime. And so this would be an example of one where you could use the chain rule. This also goes in like if you have e to the 3x plus 2. Okay, that's another one you can use the chain rule for. And your formula sheet, you'll see a lot. You'll see like you'll say like e to the u, or d over dx of e to the u. So the derivative of e to the u will be eu du over dx. And all this is saying is that you're basically taking du times the derivative of whatever is in that power. Okay. And so that's all it is. So those formulas that you'll see and those things you're going to have to memorize are just a general way of showing the chain rule for any function that we're dealing with. Okay. So this was the chain rule.